keep on moving on. Even in the dead of the night, the words are ringing in your mind. Just give them your Sunday smile and keep on moving on. Giving you blood cause you're so tired of running. Your 501s only told them you were nothing at all. At all. Held in your head, the only thing you're dreaming. Both arms up, but you don't think you can feel it at all. At all. If your heart's on fire and they're showing you a one-way sign, just give them your Sunday smile and keep them moving on. Even in the dead of the night, the words are ringing in your mind. Just give them your Sunday smile and keep them moving on. You better not look down, you better not look down. You see a shadow, you see a shadow. Don't let the feeling go. Na na na, na na na, na na hey. You better not look down, you better not look down. You see a shadow, you see a shadow. Don't let the feeling go. Na na na, na na na, na na hey. Singing na na na, na na na, na na hey. If you're
All right. Hello, everyone. It is my pleasure to announce the next speaker, Danial Senejohnny. And I'm very curious to hear what he has to say about causal effect estimation, because I love learning from lessons from people in the field. So give him a big round of applause.
Good morning, everyone. Thanks for being here. As mentioned, I'm going to be telling you about causal effect estimation. I'm a data scientist and analytics translator in finance, banking. And we are trying to use these basically tools and techniques from causal inference to answer business questions. However, the practical situation that you have is quite different than the beautiful data set that you get with nice treatment and control. And you can do sometimes with those data sets, try many algorithms and see what are the basically effect. Happily, we had very interesting talks in PyData 24 already on different aspects of causal inference. What I'm going to be touching upon is a little bit away from that theory and how a situation would look like in practice. So by no means the things that I'm mentioning would be basically a recommendation, just my lessons learned and my experience from the journey that I had. And the outline of the talk, I'm going to be basically just providing what are the practical use cases we're trying to answer with these tools and techniques. What are the standard solutions and where are they failing and how they might not fit completely into practice, the challenges, and I will also conclude the talk with some example. Introduction about causal inference, as you know, it goes further than just predicting, right? So if you could basically have the causal map and do effect estimation, you can go even further to influencing the outcome, not just predict it, but also control or influence it. The applications that are out there are manifold. Most basic one is effect estimation. You always basically take certain action and you want to see what's the outcome. It's called effect estimation in literature. However, you also have other use cases like root cause analysis that you want to see basically which factor impacts more your outcome or like causes more the outcome. Or you have also that what if analysis that looks into the counterfactual situation and so on. But in today's talk, I'm going to be touching upon two of the use cases that we are basically looking at in practice. One of them is the marketing campaigns that we basically send to our clients. And we want to see how basically clients are reacting to these marketing campaigns based on different KPIs. And also if it would impact our basically business KPIs. The other thing is sometimes financial services has some services that are basically for free, right? We provide financial consultation to our clients, but we want to know if these are actually bringing value to our clients or to us. I will start with the golden standard solution. As you have heard, A/B testing is the golden standard solution when you want to look into basically estimating effect. Of course, it's not the only experimental design, but it's one of them. In this setting, we want to look into when we are sending email to our clients and with certain content when we desire is that they either basically buy a certain product, for example. And we want to see if that's basically this email is changing anything. So in these situations, if you want to go the standard golden standard, you randomly divide your population to a group that receives the email campaign, and a group that does not. And then in this situation, if you do a proper randomized experiment, you have balance of covariates, and then whatever impact you see from the treatment to your outcome, which is basically association, is also causation. However, this is not going to hold in practice. Sometimes in practice, they forget to do this, actually. They might not be data scientists or have not knowledge about data science when they're doing these, sending these marketing campaigns in practice, the marketeers. So either they might forget, or sometimes they know, but it's either expensive or basically messes up their business if they want to work on like that. One of these examples is like in finance, when you are basically want to know what is the impact of a credit line to customer churn. If you provide a good credit line to some clients, that just to keep them, it could cause the risk to the financial risk to the bank, right? In some situations, so it's not practical. In another situation, you could assume that it could also be unethical, and you can see it like when you want to see the impact of, for example, alcohol on pregnancy. So it's not possible, right? You also have situations that the clients or like subjects might not comply with whatever you're trying to basically, you send an email to someone, but also a partner of the client also sees the email. So, and of course, sometimes there are small data to do that. So what is different in practice? This is the ideal case in theory, what you basically want to have. You are simultaneously contacting a group of clients with certain email. At the same time, sometimes you have control group. And, most of the time you have control group. However, it could be a randomized control group, but also could not be a randomized. So both is fine. But in practice, you're not going to be simultaneously contacting these clients. Because, for example, how things are practiced is you have a system based on the eligibility criteria that the campaign has, like the clients which have certain age, if they have a certain product, and based on this, send out the campaign. You might be targeting on weekly basis certain group of your clients. So not having, like, let's suddenly in one point of time contacting 50,000 or 10,000 clients, but on weekly basis, certain group of clients. You don't have any control because you have just reached out to certain clients. So you have targeted 10,000 clients while you have a customer base of 2 million. Good luck finding the control in the 2 million that would be comparable to your 10,000 clients that you have reached out. And of course, there's no randomness. What I'm going to be basically walking you through the following slides is I'm going to be building up how we can address these basically challenges one by one. I will start with randomness, and then how to define and shape a control group that's reasonable, is a good control, and of course, what to do when there's no simultaneous reach out. When we are doing randomized experiment, we have the luxury of decoupling the features impact on the treatment, because we are randomly putting clients into a group A and group B, or control and treatment, and you have a balance of age, sex, and all of those covariates that you can think about in both groups. However, if that's not done based on a randomized experiments, you always get some arrow from X to T. That means the relationship impacts the treatment. You have in one group probably more older maybe clients, or more female or male. And of course, the age also naturally impacts probably your conversion, because you know that clients who are younger probably would be willing to use email more, and they would be more online friendly. So effect estimation looks at the effect of T on Y, given how we can account for different variables in the X. And there are, of course, two schools of thoughts. One of them is potential outcome comes from statistics, and the other school of thought is basically a structural causal model, and they require basically a belief about the causal graph. And what you see on the right is actually the causal graph. So in potential outcome, you have a population, you have basically you want to reach out to these population with a group of them, with the email, and another group you don't send email. If you're in a parallel universe, then the average conversion in the group that received the email minus the average group that did not receive the email is your basically answer, right? Then you have the answer to your causal question. But unfortunately, this is not possible. This is the fundamental problem of causal inference. You can't see outcome for both groups at the same time. So then what you're going to be doing, you're going to slice that population. You're going to treat one population with an email, and you have another slice that has not been basically targeted. And then in this case, you have a selection. You're looking at an association. But when is this association a causation? To quickly look at it, if you have exchangeability, what does exchangeability mean in this context? If you do not reach to both of your subgroup of the clients, you have same conversion. No email, both group have 2 out of 10. You sending email, doesn't matter to which, both group gives you, for example, 4 out of 10. That's exchangeability. You want to have the positivity condition. What does that mean? That means you want to have overlap in your covariate distributions. If your control has some basically clients between 80 to 90, you want to also have at least some also in your control group, if that's the case in treatment. You want to have no interference. That means if you're sending email to a certain group of your clients, the other group that was isolated did not receive this. You want to have consistency, that the slice of the population that you reach out, for example, with sport, for example, email, a sport product, whatever, you don't target them also for another topic like digital products, whatever. Then you have basically interference. These are the assumptions that you need to hold. So you could do, basically, you can argue association is causation. And if you have randomized experiment, you get the first 2 for free. That's fantastic. But again, we are not in there. If there was a randomized experiment, you don't have the relationship from the X to T. But because there's no randomization, you have that relationship, as I told you. Because of this arrow that you see from X to T, your causal association that runs from T to Y, the T is treatment, Y is outcome, conversion, could also be influenced via a confounding association that would pollute your causal association. Why? Consider X as age, and you have in one group clients of between 80 to 90 mostly, and another one 20 to 30. And because of this, you are kind of opening a backdoor path from X that runs through, from T that runs through X and goes to Y. So this not only impacts basically, it also impacts the Y. And you want to fix this. You want to get rid of that arrow from X to Y. How would potential outcome treat this is as follows. They would try to find a treatment assignment mechanism that fits the X to T, and based on the propensity model, try to correct for that. So you basically fit an ordinary least square model to your outcome, which is basically the treatment, and X are the features. You get probabilities based on certain feature. You have a probability of being in that group. Then you inverse that and apply it in your outcome. So now you're mimicking randomization. Great, right? So we managed to address that randomization part. And then you see association is causation in this case if all the other basically constraints and let's say, sorry, assumptions are hold. We're going to be using this in our example. So the P is very simple for doing this in practice. You don't need any sophisticated tool, only ordinary least square. And you use these probabilities and you inverse them and you work with those inverse probabilities to re-weight your outcomes to see how this could work in practice. There's also the other school of thought, that's the structural causal models. That's a little bit different. It would basically, but works on the basically on the same concept. And normally when you apply these two, you shouldn't get you shouldn't get a different result. So basically you should be able to retrieve the same effect estimation. And there's, of course, overlap, but they're looking at more, they're looking at a more complete picture. Because with potential outcomes, we looked at this, basically, causal graph, but which, of course, we have to always account for the confounder X, for example, age that I already told you. And the average treatment effect in this context is always the coefficient of t, right? So when you fit, again, so ordinary least square, your outcome, AT, BX. But of course, the X is only going to be confounders because you have to avoid including or conditioning on variables that block the flow of causation from T to Y. So if you look at this left example, you have treatment. Let's assume you're playing music. You have Y outcome, happiness. And you have a mediator memory. So based on a music you have played for someone, it triggers a memory and they become happy. You should not, basically, if you assume that the memory is a variable that you can quantify and measure, you should not account for it in your model because then you're blocking the association that, causal association that runs through that mediator. Also, in the non-causal, you also have sometimes non-causal associations that basically both T and Y are impacting something. Consider dance when you're playing a music and as a result of this music, somebody starts dancing, but of course, because they are happy, they could also start dancing. If you condition on the dance, for example, in this situation, collider, you're introducing a bias. So these are the theory, the takeaways, and what I just told you. I'm going to be quickly taking you a little bit now to some of those practicalities that I discussed. One of them is KPI. When you want to basically do an effect estimation, it's important to look at what do you want to show that is changing to your basically business, your stakeholders, right? So how the effect is propagating, right? You send an email to clients. They open the email, probably they see it, and that could take, for example, 1 week. After that, they might basically do a little bit of orientation. They might do research. They might contact this, here, there. And they probably, some of them, not all, of course, going to take the product, right? So, of course, let's assume that this is a midterm KPI that would take within 2 to 8 weeks. And then, of course, if the client starts using the product, of course, this is not going to hold probably for many businesses. It depends. Some businesses, when you acquire a product, basically that means the revenue stream is going to be coming in. But in some other businesses, if you acquire a product, you need to use the product so a revenue stream would follow. And let's assume also, then you also have data availability things, and the long-term KPI could be impacted within 8 to 16 weeks. So now you see the effect is going from your treatment all the way to all these KPIs throughout time, and you also need to take into account the variables that are impacting the treatment and outcome. And these are of different nature. I told you it could be a mediator, could be a confounder, could be a collider. The more you go to the right side of the spectrum, you need to account to more features. If you're basically taking email seen, let's say click-through rate, so that's something like would be used sometimes by business, your life is probably easier than going to the product, because then you also need to account for features related to the product. And all the way, if you go to the revenue, then you need to also account for features that impact money. I don't know, inflation, and so many things that could basically impact that. So this is something in practice that you might need to pay attention when you want to do causal inference. So you want to promise an effect estimation at which KPI to your stakeholders. Because what you see there, this could be a little bit complicated, right? If you have T, X, Y, but then also the Ys that are passing the causal effect throughout time to another KPI. And of course, the other features that might play a role in this. Identifying a control group. Let's get back to the problem that we discussed. We need a good control. That means if you target 50,000 clients and your customer is 500,000, you can't randomly go and take a slice of that 500,000 and say this is a good control, because probably you're going to making a big mistake. There might be so many biases out there, because probably some of those 500,000 clients might not even have an email address that you send email to them, or they have email address, but they did not give you an opt-in or permission to contact them, because that's also very important. That's also very much associated to conversion. If your client is not giving you the opportunity that you reach out to them, probably that means they are not open to this, and they're not going to basically convert on whatever product. Maybe they're happy where they are. And these are some of the small things that you need to also not only look at the data, but also the business to understand, am I basically mimicking what I read in the textbooks? Am I having everything at my disposal? You want to basically reduce the bias in your control group. And my experience, how I did it, I used simple rule-based methods, right? Of course, you have that fancy modeling, but of course, to prepare the data for that modeling part, let's look at some rule-based, simple rule-based, so I could make sure that the control that I'm trying to identify and shape for the treatment is something comparable. I look at the same filters that are used in that campaign to send out email. I try to keep as many as I can because I want to have a comparable control and treatment. But of course, I will look at probably another product in the same category and family. So the campaign is sent on product X that's in the same basically family. And I will look at product Y. Of course, I'm not expecting by this choice a significant difference. Then you have some exclusion criteria to make sure those non-interference and consistency, because these clients could also be approached by a different marketing campaign, right? It could be a different email on a different product. You don't want to have these bias. Then it's good that you identify those and take out those clients out of the treatment and control. And again, you have this generic criteria, client with known email address, right? That's basic. Companies look at these filters to send out campaign. You want to look into that. And whenever you do these, then you are basically making a treatment and control that have similar characteristic. And the only thing that's different between the treatment and control is the actual treatment itself, the email that was sent to one group and not sent to the other. And this is something that you see sometimes, the power of simple tools. If you do not make a good control with the reasonable, basically, filters, and don't double check and run this with the domain expert, and just have a messy control for your treatment, whatever fantastic, I don't know, different sophisticated causal inference models you use to see what is the effect estimation, you're going to probably get a very different result, which might none of them be relevant to your business. So never underestimate simple tools and simple things that we have to sometimes use our natural instincts and natural understanding before artificial intelligence. I've got a couple of minutes, right on time. I'm going to be now a little bit summarizing in a practical example all of those challenges that I had, right? And what I'm going to be doing to fix those. So one of them was no simultaneous contact. One of the things we can do is we can, for example, postpone analysis until enough time that the data is available, and then we do. That's one approach. However, might not be the best approach. You don't want to, for example, sometimes wait, you want to proceed. There are methods to tackle these situations, use survival analysis. I gave a talk on survival analysis use cases, how could be used in practice last year in the same conference, PyData. Also, of course, there are a huge amount of literature, fantastic talks, to see how you could use this to account for cases that some of your samples have not seen the conversion yet. So you have sent the campaign, some of them have converted, but some of them could convert, but because you're early in the study and research, you might not be seeing that. So survival analysis tools and techniques helps you to address that. The second thing was identifying a comparable control group. That was what I just told you with the simple rule-based, looking at what was the filter used to reach out to the clients, try to mimic them, but of course to be comparable, reasonable, and have a good basically control. And of course, you need to, after making this control group, you want to get rid of this lack of randomization, because you have still clients that might be having different age in both groups, even though you're comparing apple and apple, but one of the apples is probably a little bit bigger than the other one. So you want to also basically address this. So what you see here on this, it's on the x-axis you see time, on y-axis you see conversion. The orange is control, the blue is treatment group. You account for the confounders that you identify. You do an adjusted Kaplan-Meier curve. These curves are basically coming from survival analysis, because conversion is a time-varying variable. Throughout each time you have different conversions, but you need to also discuss with domain experts what's the reasonable time to look at the uplift, so on and so forth. That's more or less the time I wanted to discuss. The takeaways were, how many minutes do I have? 25? It's on. Okay, so I will basically quickly look at the further reading and the takeaways. I think the takeaways were more or less clear. You need to know that when you don't have randomization, there's a relationship, and there are two philosophies and school of thoughts to get rid of that relationship. Lessons learned, make sure you are only accounting for confounding variables and not colliders. And potential outcome and structural causal model, they're just two different hats to isolate causation from causal association from other associations. Thanks for your attention, and also thanks to my colleague for supporting me in some of the examples. And the floor is open for questions.
Okay, thank you so much, Daniel.
Yeah, welcome.
Are there any questions? Yes.
Thanks for your talk first.
Yeah.
It's very interesting. In the case you have only observational data, and you have no means of or treatment, okay, went off.
The case that I've,
still hear me?
yeah.
What kind of advice would you give me? Like, what kind of methods should I use? And do I still need to control somehow how I, let's say, sample my populations, or what I do with my treatments?
Yeah. So the question, if I understood correctly, because we are working with observational data, what are the biases and how should we tackle these biases, right? That's the question.
Yeah, essentially. Okay, it's on again. And what kind of methods would you propose, which are mostly effective?
Yeah.
And if you follow further with them, how do you evaluate them?
So talking about evaluation, when you are not having a simulated data, you never know what is the actual treatment effect, right? So basically, you can never basically evaluate if, in a practical setting, whatever your analysis and finding you have is correct or not. What you can do, you can try to apply different methods and compare the results. If you are getting, for example, a same effect estimation via potential outcome and also, for example, also structural causal model and some other methods, that means, okay, probably this is something reliable. But of course, make sure about those assumptions, those 4 assumptions. Do you have positivity? Do you have a comparable control and treatment? All of these things, the simple things, before even you fit a model, are these comparable groups?
So in my observational data, I would apply these filters to the control group to see if it gets as close as possible to the treatment group. Because I cannot assign treatment whatsoever. It's observational data, so it's already done. And I have no means of controlling it. So I would just then subsample my control, like let's say the non-treated group, to be looking as like, statistically as similar as possible.
Well, not statistically, but basically just based on the rules, right? Before you do this causal inference, you want to have, because you don't have any control before, right? You make that control group, you try that this control group is comparable to your treatment group, then you do the causal analysis.
All right.
Other questions?
Hello, thanks for your talk, and interesting concept, but I have a question. Suppose there is a treatment group which receives a retargeted campaign based on his or her previous visit on a website, but then how would you know this retargeting campaign was the reason for this particular user? Because you cannot alleviate the treatment for this user and put it in a separate campaign.
Sorry, to just make sure you understand question. The case example you're providing is we are targeting, it was not the case here, but assume the hypothetical situation that the clients who visit certain pages are contacted.
Mm-hmm.
Okay?
Yeah. And then how would I know that if we didn't contact them, they would have anyways returned to the website?
Sorry,
If we hadn't contacted them, they would have anyways returned to the website. So how can I eliminate the effect for the same user that being contacted and not being contacted?
so if I understood correctly, that the situation that you're describing, right, you have clients that have visited the website as a result of the visit, they're receiving this campaign.
Yep.
How can we come up with a control group for them?
Yes.
Then probably you need to also, with the same rule, right? Which are the clients that, and again, this depends. Sometimes you're not going to have any client because the situation that your business is set up, that all of these clients are probably targeted, right? Then you're not going to have any control group. But then you're going to be having more complicated situation finding a comparable control, right? And let's assume that's not the case because then it's not impossible. Then you need to basically look at some other things to define a control. But let's assume there's possibility. Then you also go in your control, try to see clients that have visited, but they have a website on a similar, for example, product or something else, but they have not been targeted. Okay. Yeah, so you want to make this comparison basically as close as possible. And of course, I agree. Sometimes in business, you can't come with the control. I had that issue. Yeah.
Yep. So basically finding similar user to the
yeah.
Based on the rules that we used for framing the target group and use the same rules for creating a control
Yeah.
group and then,
Yeah.
okay. Yeah. Thank you so much.
Yeah, sure.
Yes, thank you for the presentation. We have the potential outcomes framework. We have the structural equation, the DAC Perl framework. In my reading of the literature, we also have a lot of focus on validity, like more from psychology and behavioral sciences, like internal validity, external validity, and stuff like that. As another framework, is that a framework you find less useful, or is it just a matter of time to go into that, or how do you see other frameworks relating to this?
What framework is this? Sorry.
So like validity, like you have Donald Campbell, like in psychology, psychologists often talk about like, oh, low internal validity or high internal validity, especially when going to more like observational data and like ecological validity. How much does this, like when you talk about field experiments and these things? So I'm just wondering, like, how do you think about?
Unfortunately, I'm not aware of that school of thought. If you could send it to me from psychology,
yeah.
I would be very happy to follow. I've not looked into that. I'm not basically informed. I don't have information.
Oh, sorry. Perfect.
Yeah.
Thanks.
Other questions? Yeah, lots of questions here.
Right. I just have a quick question regarding the. There's one slide that you are presenting, like from the T to Y to Y to Y. My question is, usually these are like, let's say like a funnel, right? So how accurate the causal inference because I can, like there's leading and lagging KPI. So I would say like the longer term it takes, the more gonna have a lot of pollutions or like bias happening, right? So what is your threshold on like, like, is that like a within action have to take within 1 week or 2 weeks to be like more accurate?
Yeah, very good question indeed. In terms of all of these basically numbers I'm giving in terms of like short, long term, probably sometimes you might need to wait a year. I mean, it's not a clear answer to that because sometimes you not have revenue, right? Data availability after, right? So you need to stay quite some time, and that's the whole thing. So the more you go to the right side of the KPI spectrum, it's more complicated it becomes. And there's no simple answer as a rule. It's different per use case. But indeed something to take into account.
Okay, final question.
Thanks for the great talk. I have 2 questions. So the first one, I was wondering in your setup, for your randomization setup, do you also consider the instrumental variable or the variable that has no direct impact to the target, but only to the predictor? And then the second question, like, how do you measure the bias or how do you evaluate from your result?
Thanks for the question. So first one was the instrumental variable. In the context that I was looking at, all of the confounders that I discussed with domain experts were measurable. So I did not have an unmeasurable confounder that I need to define basically an instrument for that. So that's the first question. The second question was on bias. What bias do you mean specifically?
The bias between your randomization effect because you implement the mimic randomization. So
Sorry, I implement what? The
mimic randomization, right?
Yes.
Yeah. So how do you measure?
You could have an estimate of your bias when you have simulated data, right? In this case, it's and that's the most of the case. So when we see basically textbooks, literature in causal inference, they're using simulated data for a data that you know actual effect. And you do apply different methods, then you get an estimate of that actual effect that you know, and then you find the gap, and that would be your bias. And then you can judge which algorithm is overperforming another one. Unfortunately, in practice, you're never going to know what's that unbiased actual effect because it's something that you don't know. You're trying to estimate it, and going back a little bit to the same question was asked before, the best practice that I'm aware of is looking at multiple methods, trying to look at your treatment and control, check it with your domain expert if there are bias in the data, the actual data. And of course, then afterward, when you have that treatment and control, apply multiple methods to see what's the effect. Because some of the methods might, for example, if you have less data and positivity is not strong, you might see potential outcome giving you strange numbers, and it's not stable. And of course, there's a big literature on stability of potential outcome. They're augmenting it with W robust, this and that. So there are a lot of literature there.
All right.
Yeah.
That's the end of the Q&A. Thank you so much, Daniel.
You're
Give him
welcome.
one more round of applause.
I don't know if you...